In this video, I want to show you both horizontal and vertical translations of a parent graph. My parent graph is going to be f of x equals the square root of x, and I want to graph g of x that equals the square root of x plus c plus d. Notice the plus c is inside the function underneath the square root sign. The plus d is after the function or outside the function. So initially c and d are 0, so g of x equals the square root of x, so it's identical to my parent graph. I've graphed them both here. They're on top of each other. You currently can't see the red one, but it's underneath the blue one. And I've also given you 4 accurate points on my square root graph. Now what I want to do is initially look at what happens when I change the value of d. I want to add and subtract numbers that are outside the function. So d is currently 0, so let me make d 2. Notice my function, g of x, is the square root of x plus 2. Notice the plus 2 is outside the function. What happened to the function? Notice every point on the graph shifted up 2 units. And when I shift from this point to this point, notice the x value stayed the same, but the y value, I just added 2 points to it, so I got 3 plus 2 equals 5. If I make d even bigger, 3, it shifted it up every point on the graph. My parent graph of f of x shifted up 3 units. So now what happens if I subtract numbers outside? So let's make d minus 2. So I have the square root of x minus 2. What happened to every point on the parent graph? It shifted down 2 units. So notice the x values of the points stay the same. The y values, you just subtract 2 from them. And if I make d even smaller, let's have square root of x minus 4. It shifted every point on the graph down 4 units. So that's what happens when I add and subtract numbers outside the function. Now let's look at what happens when I add and subtract numbers inside the function. I'm going to change the value of c. What do you think is going to happen when I make c, say, positive 3? Think about it, and now let's see. c equals positive 3. It did a horizontal shift, but instead of going to the right, when I have c is positive 3, I have an x plus 3 inside the function. It shifted the graph to the left 3 units. Every point on the graph shifted left 3 units. Notice in this case, the y values stay the same. I just take my original x value and subtract 3 from it. So if c became 5, the square root of x plus 5, all underneath the square root, every point on the parent graph shifts to the left 5. And finally, if I make c negative, so I have the square root of x minus 3 inside the function, it shifts the graph to the right. So remember, when I have numbers added and subtracted outside the function, it's a vertical shift. If d is positive, it goes up. If d is negative, it goes down. It's kind of logical. But if I have numbers added and subtracted inside the function, it's horizontal, and it doesn't really do what you expect. If you have plus 3, it's going to go to the left 3. And if you have minus 3, it's going to go to the right 3. And then again, we can combine these shifts. So if I make d2 and c minus 3, so I have the square root of x minus 3 plus 2. It takes the parent graph, it shifts it right 3, and then up 2.